Hello again, algebra students. Today we're going to continue our work with inequalities, but we're going to go beyond what we've done in the past. So beyond what you've done in 7th grade as well. If you can take a look at some of these inequalities that are graphed on this slide, we've already dealt with this kind of stuff. I don't think that we need to do all of these, but for instance, number 1, remember we're always going to start with our variable first. This is an open circle at 6, which means it's not equal to 6. So that means that it can be greater than, because it's going to the right. My arrow points to the right, just like that arrow does, and 6. That's how we write that kind of an inequality. The difference between number 1 and number 3 is that number 3 has a filled in circle. So it's still going to be my variable first. I'm still going to the right, so it's going to be a greater than. Still being compared to 6, but this time because it's also filled in, I would get that half of an equal sign. Just a quick refresher on solving some equations, because we're still solving these inequalities just like we solved the equations. If you take a look at number 1, I'm trying to get the z by itself, but right now the z is attached to the -5. So I'd want to leave that -5 alone for a moment. I would start by subtracting 4 on both sides, which gives me 2 is equal to z over -5. And then to get rid of the dividing by -5, I would multiply by -5, which gives me -10. Because this is an equation, I'm okay with it just like that. I don't care if the variable's first in an equation. In an inequality, we always want the variable to be first. Also, I've noticed some of my students that are switching inequalities during the problem to an equal sign in the final answer. This one is an equal sign because it started with equal signs. So make sure that you continue with the same kind of sign that you have. I just want to do number 2 also on this slide to compare what number 1 looks like versus number 2. They both have fractions, so there's some division in here. But in number 1, I had to get rid of the 4 first because it wasn't attached to the variable. In number 2, the subtracting 5, that is what's attached to the variable. So I have to leave that alone. I would have to first get rid of the 6 in this case, so I would multiply both sides by 6. So I would have that h minus 5 equals 6. And then I would add 5 to both sides. So today we're going to be still using inequalities, but we're going to be looking at more than just one section of a graph, more than one interval on a number line. This is what our graphs are going to look like today. Notice that there's 2 parts in each one of these. When I write these inequalities, this is called compound inequalities, I want to be able to describe each part. There is no overlap though. That means that, for instance, in letter A, I'm going to have just this part that's on the left is going to be that x is less than or equal to -6. That's what that part is. If I look at the part that's on the right, that is just saying that x is greater than, not equal to, because it's not a filled in circle, 3. And I don't have any kind of overlap. There's nothing that works over here in this left part that also works in this right part. It's because there's no numbers that are less than -6 and bigger than +3. That doesn't happen. When we have these kind of compound inequalities, we have the word or in between these because it's one part or it's the other part. It's never both at the same time. So for letter B, I'm looking on the left side. This is going to be that x is less than -5. Remember, we're always going to write our variable first in these kind of problems. It's not a filled in circle, so it's not going to be underlined with that half of an equal sign. Or x can be greater than or equal to, because it is a filled in circle, 4. In letter C, x is less than or equal to -4. This one is filled in, so it does have that equal sign. Or x is greater than or equal to, filled in, 5. In letter D, we have that x is less than -3, open circle, so it's not equal, or on the right side, we've got that x is greater than 6. This is what our inequalities are going to be looking like today with two separate parts. So our compound inequalities that we're working with today are they're inequalities, that's the graphing with the shading on number lines, but it's going to be formed by two inequalities with the word and or the word or. Today, we are not going to see any problems with and. That's going to be our next lesson. Those graphs look a little different, so today we're just going to be focused on inequalities that are the two separate parts, and it'll have the word or between them. So if I give you sentences, you should be able to first translate it into an inequality, and then we should also be able to graph it. So for this one, I've got that a number D is less than -2. D is less than -2. Remember, the less than looks like an L that got squished. Or that same number D is greater than or equal to 2. When you're graphing these, you're going to be making your own number lines most likely. You don't need number lines this big. When we were graphing before, I said we needed 3 numbers on the number line. Now, honestly, I'm okay with just 2. I want to know where -2 is because that's one of my important numbers, and I want to know where +2 is. And again, if you're writing your own, you're not going to have all these extra marks. I'll show you what that would look like. So for the left part, D is less than -2. Less than just means an open circle, and we're going to the left. Greater than or equal to 2 means filled in circle at 2, and going this way. Now, if you have number lines that are all drawn and it's really going to bother you to not have them numbered, go ahead and number some more if you'd like. If I was just graphing this by hand, this is what my graph would look like. Here's -2, here's +2. The important part on this, if I'm saying you only have to have 2 numbers on there, the important part is you gotta have them in the right order. The small number has to be on the left, the big number has to be on the right. For number 4, a number C is more than -4 or at most -6.5. Got a little cut off there, but that's okay. So C, if I say that it is more than, that means greater than -4. Or that same number C is at most. At most means it can get up to -6.5. It could be exactly -6.5, but it can't be more than that. So it can be less than or equal to -6.5. Now, I have a little bit of an issue with this, and we did this on purpose. This graph, these two inequalities, I should say, aren't really in the right order. If I would start with this, and if I had from my -4, if I wasn't thinking about where these numbers are on the number line, and I went from my -4 and I was going this way, and then -6.5, and it's going this way, it's going to look like they're going to overlap. But think about where these are on the number line. If this is -4, and let's just say this number right here is -6.5, thinking about where they would be on the number line helps. So even though the first inequality is written first, it doesn't mean that it has to go to the left. C is greater than -4 means open circle at -4, greater than goes to the right. Less than or equal to -6 would be a filled in circle at -6, and left from there. So the order that they give you for the sentence does not mean that that's what your graph is going to be in for that order. You have to really look at where the numbers are and which direction you're going to have to go. For number 8, now we have to solve. So I'm not asking you to translate on these, but I do need you to actually solve these inequalities. So where it has an or, this is saying these are really two separate problems. Please don't take anything from the first problem and try to put it with the second problem. So in number 8, the first one, I'm going to first subtract my 4 to get the z all by itself. Z is less than -2. That one's done. We're happy. I'm not going to try to graph that until I finish up both of my inequalities. For the second part, I have to get the Z by itself again. I'm going to divide by -3. And that's the part that I have said in the past I'm concerned about, because a lot of people forget when you divide by a negative or multiply by a negative, we have to flip our sign. So instead of a less than, now it's a greater than. -27 divided by -3 is going to be +9. When we're graphing these problems with the or in between, we should have one inequality that's less than and one inequality that's greater than. So that's something you should be looking for before you actually graph them. Again, I don't necessarily need to count where all these numbers are. I'm just going to say -2 is right here and +9 is there. From the -2, this is just a less than sign, which means it's going to be an open circle. We're going that way. From the 9, also an open circle, but greater than, so we're going that way. And I know that I've made this big squiggle here in between, but don't forget that you really should have the word or snuck in between there. All right, for number 9, again, don't try to do anything from the left side with the right side. These are two separate problems today. The 2 is attached to the t, so I'm going to leave that alone. Let's subtract the 6. 2t is less than 4, and divide by 2. T is less than 2. On the right side, subtracting 7. -t is less than or equal to -5. Now, I want to point something out because I know that I'm not done. I know that I need to get rid of the negative that's with the t, but in the last problem I said, you should really have one that's less than and one that's greater than. Looking at number 9, right now, they're both less thans, and that would be an issue, except that there's really a -1 in front of this t, and when I divide by that -1, that's going to have to flip or do. So turns into a greater than or equal to 5. So right here is 2. 3, 4, 5 is right here. 2 has an open circle, and we're going to the left. And by now, that kind of graphing, I'm hoping, is kind of feeling pretty easy. And from the -5, I'm going to have a filled-in circle, and we're going to the right. All right, last problem. These two inequalities, again, they are not combining. I would get rid of the 7. So I've got that x is less than or equal to 11. And on the second part of this, I would subtract this 4. 6x is greater than 12. Divide by 6. Okay. This problem doesn't work out like all the other ones, right? Because I do have a less than, I do have a greater than. But if we take a look at where these are, I would have my 2, for instance, here, and my 11, we're going to just say, is right there. From the 2, it says that it's going to be an open circle, and it's going to go that way. And from the 11, it's going to be a filled-in circle, but it's going that way. Now, the 2 did have an open circle, but when I shaded from my 11, it went right over that open circle, which really kind of fills that in. When I look at this, my entire number line is shaded, which means that any number I pick will work. Since it only has to work in one or the other, in this case, sometimes it does work in both of them. This can be any real number. That doesn't happen very often, but occasionally it does. So today's practice problems, you've got a worksheet. It's 2.5, day 1. Like I said, today we were just worried about the or problems. That's why it's day 1. There's an answer key in Schoology, and then when you're all done with that, make sure that you take the formative quiz. Let me know if you have any questions.